this video, we're going to talk about graphing linear inequalities. Our first example, we have y is less than 4x plus 3. So the first thing I want to point out is we have a less than sign. So whenever we have a less than or greater than sign, we'll use a dotted line. So first, let's plot our line. We have 4x plus 3. So we're going to use 3 as my y-intercept and 4 as the slope. So we count the 3, 1, 2, 3. And we're going to rise 4, 1, 2, 3, 4 over 1. And 1, 2, 3, 4, and over 1. To do the same trick backwards. Down 1, 2, 3, 4, and back 1. Same trick. Down 1, 2, 3, 4, back 1. Down 1, 2, 3, 4, and back 1. And what we're going to do is we're going to connect this with a dotted line. And there's our line. Now, we want to shade the section of the graph that is less than the line. So what we're going to do, since we have this point, we'll highlight it in green, 0, 0. We're going to plug in 0, 0 and see if it's true. So we're going to say 0 is less than 4 parentheses 0 plus 3. I can always use a different point that's in this section, but 0, 0 is the most convenient. So we plug it in, we get 0 is less than 4 times 0 is 0, is 3, and 0 is less than 3, so that's true. So I'm going to highlight that section. The section I'm highlighting is going to be the solution. Let's make this a little bit bigger so it goes faster. This is my solution graph. So it's everything to below the line. So we've shown it algebraically, and we're showing it graphically what the solution of this line is, and we are done. Example 2. We're given y is greater than negative x over 2 minus 6. So the first thing you might want to do is just rewrite this as in slope so we can see the slope. So we say y is greater than negative 1/2 x minus 6. So first thing we want to do is we want to take note that our b equals negative 6 and our m equals negative 1/2. So we find negative 6, 1, 2, 3, 4, 5, 6. So there's our negative 6. So we're going to go down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. And we can also go up 1, back 2, just filling in. Continue the same procedure, up 1 over 2, up 1, back 2, up 1, back 2, up 1, back 2, and we have our line. So next thing I want to point out is this is a greater than situation. So we want to use a dotted line. So this one put some dash it. So now we also want to use this 0.00 because it's also not in, it's also part on the one side. So we're going to see if we can come to a conclusion that's true. So we're going to say 0 is greater than, we're going to plug in 0 now, negative 1/2 parentheses 0 minus 6. The negative 1/2 times 0 is going to cancel. So we'll say 0 is greater than negative 6, which is true. So we are shading the section that we thought. So if we did get to a position where we had a false situation, you will see the opposite direction. And we are done. We've shown it algebraically, and we're showing it graphically what the solution set is. And we're done. Example 3. We're given 8x plus 4y is greater than or equal to negative 8. So in this situation, we have a equation in standard form. We could go about and solving this using still putting it in slope-intercept form, but it's going to be a lot easier for us to deal with the find our x and y intercepts. So let's start. So imagine we're plugging in a 0. So we're going to say 8x. So to find, remember when we have an x-intercept, the y equals 0. And for y-intercepts, the x equals 0. So we're going to say 8x plus 4 parentheses 0 equals negative 8. So that leaves us with 8. We're going to divide everything by 8. So that means x equals negative 1. So we're going to plot negative on the x. And then we're going to do this a similar trick with the y. So we're going to say 8 parentheses 0 plus 4 parentheses 4y equals negative 8. So divide everything by 4, and you get y equals negative 2. So we plot negative 2 on the y, and this time, because we have this greater than or less equal to or less than equal to, we use a solid line. So we're going to connect these 2 points with a solid line. I'm going to do the best I can to keep the line straight. So there's my line. Let's do a little bit better than that because I drew it freehand. There we go. And we do have that 0.00 still. So I'll highlight that. And now we're going to just plug in 0, 0 and see if it's true. So we'll say 8 parentheses 0 plus, let's go down just a tad so you can see my work. So we'll say 8 parentheses 0 plus 4 parentheses 0 is greater than or equal to negative 8. So 8 times 0 is 0, 4 times 0 is 0. So we're saying 0 is greater than or equal to negative 8, which this is true. So the section that has 0, 0 in it is the section we want to shade. So we already had our solution set. So we're going to shade above the line towards the 0, 0. And we are done once we're done shading. In this example, we'll go over our problem. Con and Shauna are planning to drive at most 900 miles for a road trip. Let's highlight Con in yellow and the details for Shauna in pink. So Con will be yellow, Shauna will be pink. And they're going to travel at most 900 miles. We'll highlight that important detail in green. For a road trip. Con drives at 60 miles per hour. And Shauna drives at 50 miles per hour. Let X represent the distance that Con drives. And Y represent the distance that Shauna drives. Write an inequality that represents the situation. So take note, Con is driving 60 miles per hour, and Con is X. We just write that as 60X. Plus Shauna will be 50Y, and at most means less or equal to less than or equal to 900. Okay, part B. Write three combinations of hours for Khan and Shona that will be a solution for this inequality. So first thing we want to do is graph the inequality to even make sense of that. So we're going to deal with the x or Khan intercept first. So x-intercept, we'll do that in rainbow, represents Khan. So we just say we use our inequality, 60x is less than or equal to 900. We're going to divide both sides by 60. And 900 divided by 60 is 15. We have x less than or equal to 15. We're going to plot that on the x-axis. And now we're going to deal with the y-intercept, which is going to represent Shona. So that will be 50y is less than or equal to 900. Divide both sides by 50. And 900 divided by 50 is 18. So we have y is less than or equal to 18. That's my honor. So we're going to put a dot on the y-axis. And we are going to connect our 2 points. Shrink out just a little bit so you can see everything. So since we have this point 0, 0 also, we plug in 0, 0 to figure out which way we shade. So if we say 60 parentheses 0 plus 50 parentheses 0 is less than or equal to 900, we're left with 0 is less than or equal to 900. So we're going to shade below the line. Let's make this a little bit thicker so we can shade it faster. So there's our inequality graphed. So part B is asking about points that are specifically solutions to this inequality. So we can use the point, for example, 12, 2, which will represent, and I'll just write this out, 12 hours, I'll use K for Khan, and 2 hours for Shona. There's our first possibility. For our second possibility, we can say, use this point here. That will represent 6 hours for Khan. And again, I'm using K for Khan and S for Shona, and 6 hours for Shona. And then we could also use this point here if we wanted to. That will represent 2 hours for Khan and 14 hours for Shona. And these are all points that fall within the solutions region. I could have picked any number of 3 points that was being asked for. And then what's part C? What's the maximum amount of driving hours for Khan? What's the maximum amount of driving hours for Shona? So that's essentially just your x and y intercepts. So for part C, the max for Khan is the x-intercept. So that is 15 hours. And the max for Shona is your y-intercept, and that would be 18 hours. And we are done the driving problem. I hope this helps you understand linear inequalities a little bit better.